This episode is lit. 3, 2, 1, science!
It's not magic, it's science.
Hey there, science explorers. Welcome back to iScience with Dr. White. Today, we're going to have some high-energy fun while we explore one of the most exciting parts of science, phase changes. What happens when a material changes from a liquid to a gas? Well, you're about to find out in a big way. And we thought with such a big experiment, we could use a little help from our young scientist. Joining us today is Hawk Hawkins and Luca Zito. Thanks for being here, guys.
You're welcome.
I'm excited to show you guys what we have in store. Let's start with a simple phase change we know all about, water boiling. When water heats up, it goes from a liquid to a gas. That's a phase change. The gas takes up way more space than the liquid because the molecules spread out. Guys, isn't that cool?
Yeah.
Boiling water is a great example of a phase change. But what if we sped things up? A lot. These next demonstrations I'm going to ask you to not try at home because I am a trained scientist. Let me introduce you guys to something really cool. Liquid nitrogen. Liquid nitrogen is extremely cold. It's negative 190 degrees Celsius or negative 320 degrees Fahrenheit. It's made by condensing nitrogen gas, which makes up 70% of the air that we breathe, into a liquid. We cool it down and compress it, and it turns from a gas into a liquid. What we're gonna do now is we're gonna add that liquid nitrogen and get it to change from a liquid into a gas very rapidly. And it's gonna do that in this bottle, which is gonna create a force, which is gonna launch our rocket off, just like a real rocket. What do you say, guys?
Yeah.
Awesome, let's do it. All right, here we go. All right, in 3, 2, 1. Wow! Wasn't that awesome?
Yeah.
I am totally soaked, but that was awesome. That gas expanded 600 to 700 times and it caused the force which launched the rocket. That was super cool, don't you think, guys?
Yeah.
Yeah! Now it's time for our grand finale. I've got 1,000 ping pong balls in that box over there. What do you think is gonna happen if I put some liquid nitrogen in a sealed bottle in the trash can with the ping pong balls? As the nitrogen rapidly changes from a liquid to a gas, the pressure is gonna build up inside the bottle until, well, let's look and see. Boom! Look at that! When the pressure got too high, the bottle couldn't hold it anymore, and kaboom! There's another phase change in action. The gas expansion was so powerful, it blew the ping pong balls everywhere. Phase changes are happening all around us, from boiling water to the air we breathe. But with a little liquid nitrogen, things can get a little more exciting. Thanks for joining us on iScience with Dr. White. And remember, it's not magic, it's science! Woo! See you next time! Hey there, educators. If you've made it to the post-credit scene, you're probably wondering how this episode connects to the Georgia Standards of Excellence in Science. Let's break it down. For my fourth grade teacher friends, this episode ties directly into your standards on balanced and unbalanced forces. The liquid nitrogen rocket demonstrates how unbalanced forces can cause motion. The force created by the rapidly expanding nitrogen gas pushes the bottle upward, providing a clear example of how an unbalanced force can set an object in motion. Fifth grade teachers, this connects well with your standards on physical and chemical changes. The explosive expansion of liquid nitrogen demonstrates a physical change that results in a rapid increase in volume, which is a great way to show students how matter can undergo transformations without changing its chemical structure. For my eighth grade teacher friends, this episode connects with your standards on the structure of matter and forces in motion. You can use the phase change demo as an introduction to how pressure builds up inside a closed system and how that pressure creates a force that propels the bottle or causes the ping pong ball explosion. It's a fun way to introduce concepts of motion and Newton's laws. For my high school physical science colleagues, this episode fits perfectly with your standards on states of matter and gas laws. The relationship between temperature, pressure, and volume is at the heart of these demonstrations, offering a great real-world example of how gases behave under different conditions. You can use the phase change from liquid nitrogen to gas to talk about Boyle's law and Charles's law. And for my high school chemistry and physics teachers, this is a great way to engage students with the concepts of phase changes, pressure, and the behaviors of gases. You can connect these demos to the kinetic molecular theory and discuss how energy transfers during phase changes. It's also a powerful illustration of how forces develop in systems under pressure. By linking the phenomenon in this episode to the Georgia Standards of Excellence, you can deepen your students' understanding of how energy and matter interact in the world around us. Until next time, keep those questions coming and stay curious.